Okay, so today I want to tie these trig ratios back to something we already know and are really familiar with. And that is this xy plane here. So I'm going to pose a problem. Let's say I have this point, and let's say this point is 1, 1. Okay. And let's say I draw a line segment out to that point and call this angle that it makes between the x-axis and the line segment, let's call that theta. Okay. Our goal today is, like, if I give you a point like this, you can find this ratio theta. And believe it or not, you already know all the math that would help you do this, right? Actually, if you thought really hard, you already know all the math that would allow you to find this angle, right? So I could give you a point and then anywhere on the coordinate plane, and you could actually find this angle here. Let's work towards it. Let me try to prove to you that you know how to do that. So if this, let's say we're trying to find a ratio. Let's pick our favorite ratio. My favorite ratio is cosine. So let's find cosine of theta. Doesn't really matter though. We could do sine, cosine, or tangent, right? Or even any of our reciprocal ones. Anyway, so cosine of theta would be the adjacent side over the hypotenuse. You already know that and have it in your notes. So we need to know these side lengths. And we already know that this adjacent side is 1 because my x-coordinate is 1. Similarly, we know that this tall side, the opposite side, is 1 because my y-coordinate is 1, right? So these coordinates in this type of problem are side lengths, right? Because really, x equals 1 means the point is 1 unit on the x-axis, and let's ignore the scale here, or the scale is like by thirds, I guess. Y equals 1 means the point is 1 unit from the origin on the y-axis. Okay, so that's where we're getting those side lengths. Now I need to know the hypotenuse. Well, here I can Pythagorean theorem, right? So 1 squared plus 1 squared equals h squared. 1 plus 1 is 2 equals h squared. And h equals square root of 2. Okay. So my hypotenuse is square root of 2. What that means is the cosine of theta adjacent, so 1 over square root of 2 is the hypotenuse. And if I wanted to, and I wanted to know this angle theta, I could plug this into my calculator and use the cosine inverse button, and I could figure out that angle, right? We've done that before. Let's go ahead and rationalize this. So rationalize, I do times square root 2 square root 2. So I get square root 2 over 2 would be the cosine of theta. Okay? So that's what we're doing here. I'm going to give you a point. You're going to figure out a trig ratio based on that point. This is like, you can imagine like your guy in a video game standing at the origin and having to turn and look at a certain point, right? So in like your Fortnite shooting type games, for example, this is the kind of math that they use to make those calculations about how far you'd have to turn to see a certain point on your screen. Let's do a couple of examples. Okay, if theta is an angle in standard position and its terminal side passes through the point 4, 9, find the exact value of secant theta in simplest radical form. Okay, so standard position just means it looks like how we just saw. So theta is that angle from the x-axis. 4, 9 is our point. We're looking for secant. So here I pulled the drawing off of Delta Math because it's going to be better looking and clearer than any drawing that I make for you. And here that is. So here's what this looks like. So notice we've already labeled the sides. So the tall side is my y-coordinate, because 9 is the distance along the y-axis the point goes from the origin, and 4, the bottom side, is my x-coordinate of the point that they gave me. Okay, so we want secant theta. So secant theta is the opposite of cosine. So 1 over cosine, which would be hypotenuse over adjacent. Okay, so what we need here is to find the hypotenuse, right? Because we have, if theta is here, we have that adjacent side. So let's go ahead and find that third side. So we'll say 4 squared plus 9 squared equals h squared. And that ends up being 16 plus 81 is 97 equals h squared. And then h is going to be the square root of 97. Okay, so that's my hypotenuse. I'll go ahead and throw that in my picture. You're going to want to draw these triangles in your notebook as you figure these out. You're not going to be able to do it without drawing. So make sure you draw for every single problem. And so we have square root of 97 is my hypotenuse. We want secant of theta is hypotenuse over adjacent. So that's going to be square root of 97 over 4. And conveniently, my square root is on top, so I don't need to simplify that at all. So that's my solution here. Okay. And again, the usefulness of this is that I could go back and figure out that angle if I wanted to. We'll do one more. Okay, here is my last example. This is a great one to catch in your notes because it has all of the tricky things here. So what we notice right away is we have a negative in our point. So this is the first time we've run into negatives dealing with these trig ratios, other than maybe like a result on your calculator. We want the exact value of cosecant, so it has our inverse trig ratios as well. So again, great example to have in your notes. Capturing this one, at least, like even just this will probably help you through your problems here. Okay, so I've got the picture from Delta Math I'm going to give you. If you're doing this on your own, you would draw, right? So you draw XY plane, and then you draw a point at 1, -8, draw a line segment. So we'll do this. So here is my drawing. And notice, like, this distance is 8. We're going to label it -8. Right? So the labels correspond with the points. And that's going to matter sometimes in your solutions. Okay, so what we're going to do now, we have theta. We want cosecant of theta. So cosecant is the reciprocal of sine, right? So sine is so katoa. So this is going to be hypotenuse over opposite. So we need to find the hypotenuse. So I'll use Pythagorean theorem. 1 plus -8 squared equals h squared. 1 plus 64, and that should be positive, right? If you type this into your calculator without using parentheses, it will misinterpret it and give you a negative. That's wrong, right? So a negative times a negative is a positive. Equals h squared. 65 equals h squared. And our hypotenuse is the square root of 65. Okay. That does not simplify. You can check if you don't believe me. I'm going to label that in my triangle. And then I have enough information to answer here. So cosecant of theta is going to be hypotenuse, root 65, over, and opposite is -8. Okay, so that is my solution. I want to write it just a little bit nicer. I'm going to write the negative either on top or in front of the fraction, just because it makes it a little bit clearer. So that's my solution, and that's exactly what you typed in Delta Math. Okay, so this is sort of a new level of thinking here, a new level of analysis with these triangles. Make sure, before you move on to the problems, make sure you understand this problem, how I did it that's on your screen, and make sure you have good notes.